Students. The next thing that we covered after exponential functions and logarithms in the second semester was we learned about some sequences and series. We learned about two special types of sequences referred to as arithmetic or arithmetic sequences and geometric sequences. An arithmetic sequence is a sequence that uses addition to go from term to term to term. So notice here in this first example, the first term of a sequence is 3, the second term is 10, the third term is 17, the fourth term is 24. We can clearly see that we're adding 7, adding 7, adding 7. So this is, by definition, an arithmetic or arithmetic sequence. We learned that arithmetic sequences have an explicit formula, a sub n equals term 1 plus the common difference times n minus 1. So here we would say a sub n equals 3 is the first term plus 7 is the common difference times n minus 1. Now, I could say that that's the explicit formula and just stop right there, but sometimes I like to distribute the difference and clean up the formula. So I could say a sub n equals 7n. If I distribute that 7, I have 7n minus 7. And then if I add the like terms, 3 minus 7, I have minus 4. So a sub n equals 7 times n minus 4. Well, you'll notice that that is the correct formula for this sequence. If you plug in 1, 7 minus 4 is 3. If you plug in 2, 7 times 2 is 14 minus 4 is 10, and so on. So that formula seems to be working. Find the 50th term of that sequence. Well, now that we know its formula, a sub 50, the 50th term, is 7 times 50 minus 4, that's 350 minus 4, and that's 346. The 50th term of this sequence, if it kept going and going, would be 346. What term has a value of 136? Well, that means plug in 136 as the value of the term, so that's 136 equals 7n minus 4. So if I solve this, I add 4 to both sides. So now I have 140 equals 7n. Divide both sides by 7, and I see that n equals, it was the 20th term that had a value of 136. Okay, coming over to the right side. Geometric sequences are sequences that multiply to go from term to term to term. So you'll notice 3 times 4 is 12, and 12 times 4 is 48, so this must be a geometric sequence. The explicit formula for a geometric sequence is a sub n equals a sub 1 times the rate to the n minus 1 power. So for us in this example, it's a sub n equals 3 times 4 to the n minus 1th power is the formula that generates that sequence. So then if I say what is the 10th term, that's a sub n equals 3 times 4 to the 10 minus 1. So that would be 3 times 4 to the 9th power. And that's going to be a very, very large answer. Grabbing my calculator, 4 to the 9th power, but then times 3, 786,432 is the 10th term. That's pretty amazing. The first 3 terms are 3, 12, and 48. Just a few more terms out there to the 10th term is 786,432. Multiplying by 4 grows quickly. What term has a value of 12,582,912. Well, would that say set 12,582,912 equal to 3 times 4 to the n minus 1? Oh my God, that's an exponential equation. I know how to solve exponential equations. Divide both sides by 3 to isolate that base. So let's see, I need to find 12,582,912 divided by 3 is 4,194,304 equals 4 to the n minus 1. Well, now I can change that to log base 4 of 4,194,304 is equal to n minus 1. So grabbing my calculator, if I pull up my logarithm and I give it a base of 4, and then I type in that great big 4,194,304 and press enter, the calculator tells me 11 is equal to n minus 1. Add 1 to both sides, and we have found that it was the 12th term. That was 12,582,912. Okay, that was a big review of most of this chapter on sequences and series, but let's keep going. We gave you these slightly more challenging problems where I would give you just 2 terms of a sequence and ask you to find its formula. So let's take a look at a couple of examples. If an arithmetic sequence has a 5th term of 19 and a 12th term of 61, what is its formula? Well, let's see if we can figure this out. The first, second, third, and fourth terms are unknown, but the 5th term is 19. The 6th, 7th, 8th, 9th, 10th, and 11th terms are unknown, but the 12th term is known to be 61. Now, if this sequence is arithmetic, that means it's adding to go to one term to the next. You would be adding the common difference. Well, how many times would you add the common difference to go from the 5th to the 12th? You'd add D 7 times to go from the 5th to the 12th term. So can I say 19 plus 7D must equal 61? And if I do a little bit of algebra, subtract 19 from both sides, 7D equals 61 minus 19. I'm having a bad day, I need my calculator, is 42. So I guess I found that D is 6. Well, do you remember that the equation of an arithmetic sequence is A sub n equals A sub 1 plus D times n minus 1? So I now know that D is 6. But in order to build my formula, I still need to find term 1. So here's term 1. Well, now that I know that D is 6, can I go minus 6 is 13, minus 6 is 7, minus 6 is 1, minus 6 is negative 5. So I can go back and find that first term is negative 5. So now A sub n equals the first term plus D times n minus 1. So now that's A sub n equals negative 5 plus 6n minus 6. 6n minus 6. So would that be A sub n equals 6n minus 11 is the answer. Now, if you don't think you're right or you want to find out if you're right, you should be able to plug in 5 and get 19. 6 times 5 is 30 minus 11 is 19. you should be able to plug in 12 and get 61. 6 times 12 is 72, minus 11 is 61. So I feel very confident that I found the right formula. Okay? Next, if a geometric series has a fourth term of 20 and a 10th term of 14,580, what is its explicit formula? All right, let's draw a picture of this one. The first, second, and third terms are not known. The fourth term is 20. The fifth, sixth, seventh, eighth, and ninth terms are not known, but the 10th term is 14,580. Well, wouldn't we multiply by r, multiply by r, multiply by r, multiply by r again, multiply by r, and multiply by r to go from term to term because it's a geometric sequence. So could I say 20 times r, 1, 2, 3, 4, 5, 6 times, r to the sixth equals 14,580. So I need to solve for r. So I'm going to divide by 20 on both sides. R to the sixth equals, grabbing my calculator, 14,580 divided by 20 is 729. Now, if r to the sixth is equal to 729, then r is equal to the sixth root of 729. And with my calculator, I can find that to be the sixth root of 729 is 3. So I have found that r is 3. Okay, so now this is going times 3, times 3, times 3, times 3, times 3, times 3. Well, remember, a sub n equals a sub 1 times r to the n minus 1 if it's a geometric sequence. So now I know that a sub n equals a sub 1 times 3 to the n minus 1, but I need to find a sub 1. Well, couldn't I divide by 3 to get this term, divide by 3 to get this term, and divide by 3 to get the first term? 20 over 27 is the first term. So a sub n equals 20 over 27 times 3 to the n minus 1 is the equation that I was looking for. Okay. The next thing we learned is about series. So remember, a series refers to adding the terms of a sequence together. So I taught you about the arithmetic series. Definitely ask me more questions in class on this if this video doesn't bring it back to you. If you have an arithmetic series, I taught you about that little boy Carl Gauss that says the sum, capital S, of the first n terms is equal to the number of terms divided by 2 times the first number in the sequence plus the last number in the sequence. So like for instance, if I said find the sum of the first 100 terms of the sequence 3n plus 8, could you imagine doing that by hand? The first term would be 11, plus the second term would be 14, plus the third term would be 17, all the way out until you got to the 100th term, which would be 308. That would take a long time to do from left to right. 11 plus 14 is 25, 25 plus 17 is 42, plus. That would take forever. Well, Mr. 9-year-old Gauss says that all you have to do to find the sum of the first 100 terms quickly is take 100 divided by 2 times the first number, which we see as 11, plus the last number, which we see as 308. So that would be 50 times 319. And if I grab a calculator, 50 times 319 is 15,950. If you were adding from left to right, you'd still be quite busy. Okay. And final for this video is we also learned about the geometric series. If you're trying to find the sum of the first n numbers in a geometric series, it's equal to the first term times 1 minus the rate to the nth power divided by 1 minus the rate. So like for instance, I want you to imagine the long way if you had to do this problem. Find the sum of terms 1 through 20 of the sequence generated by 3 times 2 to the nth power. Well, the first term would be 3 times 2 to the first, 6, plus the second term would be 12, plus the third term would be 24, plus all the way out to the 20th term. And if I raise 2 to the 20th power and multiply that by 3, the 20th term is 3,145,728. Okay, you have fun with that. 6 plus 12 is 18, plus 24 is 42, plus 48, plus 96. That would take forever. Well, my shortcut formula says take A1, which I see is 6, times 1 minus R is 2 to the 20th power divided by 1 minus 2, 1 minus R. So that's 6 times something over -1. Well, let's see. 1 minus 2 to the 20th. 1 minus 2 to the 20th power is negative 104,875. So if I multiply that by 6 and divide that by -1, my answer is 6,291,450 is the sum of the first 20 terms. Now, you'll also remember that I taught you that you can sometimes find the sum of an infinite geometric series, but I'm leaving that off of the exam. All right, so that finishes our second review of sequences and series. Certainly ask me to do more in class if you need.